See, yeah, I very patiently listened the earlier speaker and everything right from beginning of my life, I tried to explore my own potential. That was the whole thing. And to the extent I can actually exert myself, not looking at what I gain, but I wanted to explore my knowledge. Up to what extent I can explore that. That was driven. So philosophy, it varies from person to person. So my is, and you will find it through my work, kind of work, and the I would say uniqueness. Okay. So at the very onset, I thank IEEE President Prithviraj. He has given very cordial and fervent request to deliver a lecture, and it is kind of, I thought from his letter, I just observed, it is kind of, sir, why would you give a lecture to us? So I am an emotional fellow. I am a very emotional and sensitive. And I made use of my emotions and sensitiveness into my work. So when I work, then I do not even tolerate myself. So and other emotions I don't care. Because you will find from that work. You will find from that. So and thanks to IEEE's USB Counselor Professor S. Mukherjee, she also actually invited. So it's a very wonderful thing. I always actually look for such audience. And as you all know, Calcutta University, so we do not require people like us to elaborate much on this. Once upon a time, it was one of the top 3 universities in the whole world. So what else one can tell about Calcutta University and such a platform you offer? And I am very, very actually passionate to kids and passionate to the people who are really doing work from their heart actually. See, anything what you do that should have some sacrifices, some challenges involved. So not that something is spoon-fed. The system is there, you are making use of it and doing something because you are given that luxury, that facility. So this is an obvious case. Out of all those given or not given, if you are doing something that is unique. So with that was my whole thing. So I never thought I would tell I am a doctor from Oxford University. Why I should tell? Even after Oxford University, I joined IIT Delhi as a visiting faculty. Then I joined IIT. The IIT director used to love me a lot. Even in front of all the faculty members, he said, how many of you have seen Professor Pal's biodata? So I think it's unique in the IIT system. So still within a year I left. Then he was actually a little bit odd and asked why you are leaving. Then I said, no, I have to do some work. And that's what even Oxford doctor didn't please me. Why I should say? Why I should say I am a president gold medalist in IIT? Why I should say I am a scientist in NASA? My work should tell. I didn't do any work from Oxford. So when I was in IIT, I got a call from University of Birmingham, the leading scientist in superconductivity. And fortunately, that superconductivity field was my field in active doctorate. So I never left my line. So it's always electronics and the heart of electronics, that maths and physics, that is electromagnetics. So I wanted to be in applied electromagnetics. So that was my theme right from 1992. I never deviated. And I was too strong in maths and physics in comparison to the normal one. Just by saying one thing I can tell you, so in those days, out of 200, I get 190 marks in physics in 2 papers. And my rank in engineering and medical both was around 100. So it is that way I have actually that confidence, but I never used to speak to anybody. Another good thing I can tell you, because you are student, so no, I was a very shy fellow. So I started talking to people at the age of, let's say, 42, 3, when I became HOD of BIT Mesra. Then when I was married, up to the age of 38 years, I never used to speak to anybody. My in-laws, they used to say, he only can smile. He doesn't speak. I never used to speak. And wherever 2, 3 persons, I never go there. Even today, I don't go there. It's all rubbish. Because I have potential, I let me explore my own potential. So with this, I'll start. So that's a normal thing. See, it's a kind of thing which you should actually feel for it. Everything you do with a feeling, then only you will be successful. And real success, that fulfillment will come, enjoyment. So a little child is asking curiosity about his own career. A wise man, here he said, in which I could make a career. He said with a smile, be a good human being. That is no competition, lots of opportunity in this world. So it need not necessarily be you have to do something, study, all these things. So there are plenty of qualities which are required, which are admired, which should be so by that. Then with this step, yes, I was a shy until up to the age of 38 years. But I knew I was too good in maths and physics. Then I was doing actually, because of the family problem, I was doing my engineering after gold medal from Jadavpur University in Masters in microwave engineering. I specifically chose that because microwave engineering happens to have the maximum amount of actually mathematics and physics. I don't think any other field in electronics is there. But while delving into certain fields, to the extent of depth, you will explore many other fields. So I have explored almost all physics and mathematics, whatever people these days talk about. That is again all by myself. So it's my self journey more than what I could deliver in terms of the students. So opportunity, safe trust, this is delving. That's it. A trust with knowledge and potential in the mid organization. That raised hairs when I got this. When I just entered into Oxford, all the hairs were raised, seeing the stone wall buildings and all. Then I thought, if I am not successful, right at the very point of time, I thought myself, if I am not successful at the time, then I should not come there. As long as I tell to my student, as long as you are having food and a shelter over your head, top, roof, if you have a roof, you cannot complain. Why? Rest of the things you are supposed to do. That is my principle. I exerted myself to that extent. Even doing today I am doing. You will not imagine what I am doing. So this is Oxford, so no feedback. I didn't receive anybody's feedback. I don't receive. No looking back, obviously. This is my own, everything I write of my own. So now actually superconductivity. So it is actually the thing. I don't think even today, so I did it in 2001, I started 1st January. So even today in India, high temperature superconductor was then just actually evolved or came into being in 1986. But in the field form, material form, because on which you have to make a device, in that form, it came around 1995. And I am going, after serving 8 long years in an industry, Bharat Electronics Limited, though I didn't leave my studies. Even during these 8 years, I used to continue study because I love studying since my childhood. Most of the people let us say, if somebody serves an industry for 8 long years, he will forget everything. I didn't forget it because though I didn't have doctorate, still Oxford chose me as a postdoctoral fellow. Why? I didn't have a doctorate. Oxford chose me in a postdoctoral position. The post was advertised for postdoctoral position. And you know what? Seeing my biodata, Professor gave aside all the biodata. How do I know it? when I joined that administrative assistant, they told me, seeing your biodata, Professor kept aside all the biodata. Because I had 8 long years of experience in BA. So they deducted 3 years for PhD, and though I didn't have doctorate, I used to get what a doctorate fellow would have got, 5 more increments than them. So I was getting huge salary. Even 2 years of time, keeping my family there, I saved around 22 lakhs rupees of money. And I bought a flat in Calcutta, and which is amounting to now 1.5 crore. So I thought, superconductor just came into me, so it's a good opportunity, so now I should do it. So what else can we do? Because superconductor is a lossless, and everything we pay because of the loss. See, any material, any technology, any concept, whenever we delve into once we delve into the loss mechanism. What are the factors creating losses? How to mitigate those losses? And what are the ways, possible ways to mitigate losses? So when I was doing this superconductors, then I thought the loss of a superconductor is almost 1,000 of copper loss. When you say in terms of communication, transmission, when you say your part system, if you can replace all those, the amount of transmitter, the weight, size, and the cost, because the bigger this transmitter size, the bigger will be the cost, and bigger modules it will be involved. So how to mitigate? So if a fellow which is having 1,000 times more loss, so with 1,000 times less loss, would not occupy that much of big volume, would not involve so much of cost, so that can Americans afford. But the thing is, at what condition, what that fellow requires, it should be superconductor. So 1986, when two IBM scientists explored that superconductors can also be built in actually after liquid nitrogen, boiling point of liquid nitrogen, 77 Kelvin. So there are 2 superconductors came into being actually. So one is TBCC, helium, barium, calcium, copper oxide. Another is yttrium, barium, copper oxide. So one is having around 87 Kelvin actually, your critical temperature, another is having 100 Kelvin. So both are above liquid nitrogen. Liquid nitrogen is available, is very cheap. In the sense, 1 liter of the liquid nitrogen in Europe, those days I learned many things from Oxford. And Oxford actually changed. The what way one should look at. Oxford changed. So they say 1 liter of the liquid nitrogen costs less than 1 liter of bottle of Pepsi. So it's so cheap there. Maybe it's not. So they use it. So then and you see, because anything is lossy, and if you look at its frequency phenomena, so it will be gradually drooping. If it is less loss, say in the case here,
it will not work.
Pointer
The laser pointer will not work on the particular screen.
pointer will not work.
only slide up and down.
It will work on upper screen, but not on this particular screen.
No, but yes. So normally in any communication service, because the spectrum is congested, so it is every application would be having nearby. Here. Thank you very much. This one can listen.
No, sir.
Now,
इसके लिए pointer transfer
you have to be a very good human being first. सीधा अच्छा को अच्छा बोलना पड़ेगा. Otherwise, no chance. I can tell you. So if you look at it, so because there is the depth of spectrum, so I require my services. With time goes, we require what many services to actually to have. So they are very close this space. So if I having a filtering response which can allow, actually here, this is actually coming in stop band. So it is normal conductor, this one, because this sharpness, this selectivity, this rolling off from pass band to stop band is gradual. That is all due to the losses, the Q factor. So if I compare, which I will show in later one, all those things I have done single-handedly without anybody's help. So again I am telling, I am very thankful. I am very, very thankful because still it is my journey only. Because if Calcutta University doesn't get students, if IIT professor doesn't get students, so I cannot tell I am getting students. Last 5 years, I don't have any PhD student, I don't have any MTech student. But am I stopping? No. Rank which is below the noise floor level, so that cannot be detected. So now, if the noise floor level is low, and by using superconductor, that signal same strength is picking up, looking up, so you are able to catch it. So from there, that's what I will tell. You can size your wave reduction. So anyway, so quickly, some understanding. So I observed actually the normal conductors, copper, normally say copper. The surface resistance is actually one of the prime factors surface resistance to tell about the quality of actually that your material. In my case, actually, I have used thin film. So it's thin film in the sense actually there is a substrate on top of it. There will be a layer of very micro layer. On top of it, it is actually various ways of actually RF sputtering, thermal evaporation techniques and all. So what we see for normal conductor, first resistance it is actually proportional to F to the power half. That means square root of frequency. But in superconductors it is F square. But then that being the case, then this one surface resistance will be much more in case of this. No, it is in this case, if you look at it, up to the frequency, from lower to that, then bigger to this, is much lower than copper. Then beyond the frequency, which is actually almost, if you look at it, 100 gigahertz, then after that, copper is actually taking over. So superconductor, if somebody wants to use, it has to be used around 10 gigahertz. So that is one. Another important phenomena. This is very, very important. Those who are doing electronics components development, design, development, understanding physics, mathematics. I always go to the physics, real physics and real mathematics. That's from the basics. Normal conductor skin depth. We know skin depth is square root of 2 pi 2 divided by omega mu epsilon sigma. So it is otherwise 1 over 1 by pi f mu sigma. Here it is constant. That means what? That means it is not related with frequency. That means it is, if anything related with frequency, that will give you a dispersive nature. The velocity of various frequency components will be different, but different. The group the phase velocity of various different components, frequency components will be different for different frequency. But if the penetration depth, as because the penetration depth is it's related to that, it is actually constant. So all these components will go in tune, in unison. So there is no dispersion. So that is the idea. And it is also, now actually what is superconductor? What is superconductor is different. So it is based on the London's two-fluid model. So simple circuit. Here you have superconductor. It is for normal conductor Jn, which is a resistive one, and this is actually the imaginary one, which is actually shown as inductive. It is actually superconductors, and it is very low value. And because of the London Cooper pairs, and Cooper pairs is kind of very fast because they move very fast in pairs. So that way it is giving a less resistive path. So this is about that, and there are 3 prominent actually substrates. So just quickly this one. So what I have done that I will tell, because these are all my own made setup and own made measurement in Oxford. So, and Bahar mein suvida ye hai, the beauty in abroad, everything you have to do alone. No research assistant. So that is actually the difference. Everything you have to do alone. Your work is yours, both in postdoctoral and doctoral. Even my supervisor never used to come and see me. Never used to ask me to submit report at both places. Because they are so satisfied actually getting result week after week from me. The measurement is subsidization. So now actually normally for any or something like that, you have to make it closer, proper enclosure, and the other support, and it's a film, a substrate on top of this film. The one actually you want to measure similar kind of this, you have to go, and that is a sapphire part, that is a sapphire dialect, seeing that kind of thing. These are actually the probe, some kind of loop, which can actually collect, and then outside it will be going to the measure. So it's called dielectric cavity resonator. So it is with that actually it is measured Q factor of superconductor by this one, the TP65 3,20,000. So any for copper conductor it is around 1,000, maximum 10,000. So this is very low, at 10 giga. For copper it would be much. So that's why the effect is that superconductor is fast, and it is you are actually making use of so much of bandwidth. It is grouping that way. So now, so this is about superconductor because just a little bit. Now this is actually my first filter, self-developed, self-designed, self-fabricated, self-tested. No second person involved. It is put in here. The feed box of the world's largest radio telescope. It is in BIT Mesra's this one list of accomplishments since 2009. So, and what is the what or what is the problem in a nutshell? In a nutshell, that is actually the largest radio telescope. 110 meter diameter. It is situated in West Virginia, US, at the place called Green Bank, and it can see the entire sky. Because it is such a huge structure, obviously it will have a tower. So it will not allow you to see all the things because it will touch the ground. So 5 degree to 175 degree. That 5 degree is not for not allowing it to touch the ground. So that much of gap, you have to leave it out. Then 5 degree elevation to 175 degree, this side, so it can observe. It can observe the entire sky. What was happening? What was the problem? And see, when I got to know about this problem, I was in IIT Roorkee and well praised by IIT director and HOD. I am leaving. Why I am leaving? I am leaving. This is the work I have got by which I don't have to tell I am a doctor to Oxford. My work will tell because I am no I can see. That is the challenge. And you know the challenge behind the sad part behind this story. When I was catching the fly, my father, he's also a president of India awardee. He was telling, I have not seen anybody in this country who is leaving permanent IIT job and going for a postdoctoral for future uncertainty. I was catching the fly. I was so demoralized. Then that made me further, no, I have to do something. And he again called my wife. I got my son married to you, not to take him away from me. So I am, these emotions work. I am telling you again, for me I work. So I will not tell you should do it. And this is an opportunity you have given me, I am so thankful for it. So now the problem was, so there are lower arteries because it can sense, because the diameter is 110 meter, so almost you can imagine, So almost 10 meter is corresponding to an order of a signal it can enhance the gain of an antenna. So if it is 110 meters, so 10 into 11, so that means almost 110 dB. That one. So that corresponds to actually a signal which is received from a distance, and it can gain up to 10 to the power 11. If I increase the distance by 10 to the power 11 times, I will receive the same amount of actually signal. So that's why it is able to explore billion miles. Here it is written. All the features of this one is written. It can sense even gaseous molecules present billion miles away. This is the most higher telescope, or rather lab in the entire world. Why? Because it is serving almost 75 universities. This is under the University of Cornell. Okay? Cornell University is maintaining that. And many things I got to know about, learn about this one, because I have to interact with those people, astronomers who are actually involved in maintaining EGV. So there they said, I said, what are the particular that is the characteristics of this, the qualities, the characteristic features of this one. Then they say, your filter has to be very, first thing, lossless. I said, what do you mean by lossless? Everything has got loss. Some measurement loss. Then they said, if the 0.1 dB loss in our observation time period should be enhanced by 18 hours. How important that? Because they are observing an astronomical phenomenon. If a system is having additional 0.1 dB loss, in order to isolate or distinguish that phenomena clearly, I have to observe 18 hours more. That is one thing I learned. Great, oh my God. इंडिया में तो सब 2-3 dB खा जाते हैं, कोई बात ही नहीं करते, समझ भी नहीं पाते। आधे से ज्यादा लोग तो मैथमेटिक्स ज्यादा नहीं है। I felt it. तो ये जो चीजें हैं, 0.1 dB loss, instrument here it would give 18 hours observation time to get it. You want to isolate that thing, keep very well. So then they said that I said, so much of gain, then how do I tell about how much weak signal it can calculate, can sense? Then they say, a signal, a weak signal, which is of the order of 10 to the power 5 times less than the noise floor level. So let's say noise floor level is 60 dB. Let's say. So which I have seen actually, copper you can get normally 40, 50, 60 dB. In superconductor you get around 80, 100. Okay, in superconductor. So let's say it is 100 dB noise floor level. And this gain fellow, this 110 meter diameter, this 10 to the power 11 times gain. So signal of 110 minus 50, 160 dB down, signal strength. Minus 160 dB down. My noise floor level is minus 110 dB. That also can be due to how can that be possible? Something is noise floor level is my 110 and 10 to the power 5 times low, 50 dB down, so 160 dB down. How can that be said? So that is actually multi-level of statistical signal processing. We used 5 times consecutively. 5 times of multi-level, those telescope people they do it. Why that way? Even the noise, which is actually buried into the noise, which is normally is well buried into the noise floor, still they can imagine. That is actually, now the problem was, the telescope was not able to collect or not able to see the universe over a 16 degrees holiday. Why? Because lower Earth orbit, there are satellites. So lower Earth orbit is generally 1500 to 2000 kilometers. Those satellites are normally from Earth surface, 1500 to 2000 kilometers. Normally every country has 4. and obviously it is closer to Earth, so respective zone will be illuminated. So that's all. No, it's not geosynchronous center. 120 degree you can see. So now when it is signal, now the satellites which are sending the signal and facing this antenna, which is having so much of gain, so it was so amplified that correlator, digitizer, what is at the front end of the telescope, it was getting overlapping. So like a digital clock, all aids, no time. So all aids. So when it is actually that digital correlator, which is at the front end of a receiver front end of that telescope, so it was overloaded, so it was, then that is actually stopped, the antenna. What they used to do then, and it was a problem since their inception, since its birth. So what they used to do then? So they used to do such a huge structure using a manual pulley kind of system, get that 16 degree out of zone, then restart. Now my filter is put and continuously, and it was flashed by them, and I was actually informed later on. It is first flashed in America that GBT revives its birth problem. Then they said, we had congratulated, no, Dr. Paul, your filters are working exceedingly well. Seeing the age-old problem solved, our astronomers are jumping in joy. What best a man can get. So I didn't get any award, I didn't apply for it. Anyway, that is actually the problem. Problem is, and I will tell you why I am behind here now, because that is the story everybody asks me. I was in IIT, I never, before joining BIT, I was not knowing of BIT. There is an institute called BIT, Mesra is there, I also don't know. That is the reason why I left. So now, actually, Indian request suggested, there is a well, very established actually in this one. So it is all told, and it is specifically mentioned that 110 meter national, that is radio astronomy observatory, that is NRO, and they wanted to eradicate strong satellite digital and audio radio signals of GBT. So because it was stopping their antenna rotation, thereby the observation of the universe. Because once it is stopping, antenna is not stopping, so you cannot get the signal. Because all the signal is coming as a saturated level. So you cannot get the actual signal. So to meet that requirement, I developed two miniaturized pseudo-elliptical designs of high temperature superconductors. And in fact, what they were asking, these filters are working and ordered in our field, it is 10 times. 2 orders, it is scheduled for 2 times, 100 times. So, it was a warning since 2009. And it is actually the filter. So it is actually, I would not go because it will be too much of a distraction. Because all these things are, if somebody, this PPT I will limit, if somebody is interested or something like that, you can approach. So which was 40 dB here, there's some specification frequency they are asking, because this frequency, 232045, it is only of 25 megahertz. So 40 dB by 25 megahertz. That 40 dB by 50 dB, I have given 25 megahertz. 50 dB. So 1 order further. So it is further speed. So it is so they are very happy. Then these telescopes are put into these filters are put into the telescope. So this is the details of the telescope. So normally you will not find it. And regarding this, I can tell you my designs about these designs. I can tell you because I get many queries from ISRO DRDO scientists. And to my observation, nobody has done any filter, superconducting filter from India, either in research lab or in any academic institute. My main filter is 2 dB telescope. So this is not the normal design. I wanted to miniaturize it. And normally the principle which is given, this is the transmission line, and you can imagine it is a slant series resonant filter. So it will give notch. I am making it bend in order to miniaturize it. So the angles are also getting changed because of this length. So you have to adjust it so it's not uniform. So this transmission line Z0 with this electrical length theta 1 impedance I have kept same because if we see the wave it remains the same. Theta 1 is the electrical length which is corresponds to the physical that is in law. So beta L equals to twice pi by lambda into L. So here theta 2 theta 3 go. When I pursue the research paper, very famous research paper, when I was doing that, our lady, those kind of people, I always go through those papers only. The pioneer. I don't read anybody else's paper. Even today. No. Never. So they are given in an order. I find no, it's not working. I mean, I'm trying to do. Then I changed it. Then I am getting exactly. So it's not. So it is published in IQ. I could have patented it. I could have earned thousands, hundreds of those. I didn't do it because I thought this one. So these are actually. This is my actually fabricated filter. You see, and this is actually measured when this is the telescope. This is actually the pulsar observation. They have removed the band. And after that, they actually published a newsletter. And they, after 21 days, publishing after 21 days after publishing, this is actually the test bed I have used, microwave probe station, trial pool, while testing in Birmingham University. It's my test. That is their testing. So this is one contribution. So GBT bands stop filter. Then I thought, actually the work was for 3 years. So I finished it in 9 months. I slowly calmed down. I finished it in 9 months. Then I asked the professor, what shall I do? What if you could have done? Tell me. अब घूमने मजा करते 3 साल बिताते हैं A to Z. जितनी भी बड़े प्रोफेसर्स IITs, FIITs सब हम देखे हैं. हम बोले नहीं सर, I cannot sit idle. At least पापा को बोल सकते हैं. Now see, world largest telescope is prepared. Then that was band stop filter. Now I thought there is another filter, and which is actually a combination of actually low pass and high pass. So it starts with low pass, we derive it high pass, make it in band stop form, band pass form. Hey, you know the mathematics behind it? Anybody? How many of you are interested about? See, if any function, so it can be applied in any field. My realization of one knowledge can be applied in many knowledges. A mathematical function fx, if I have an inverse function f 1 by fx, okay, and if we do simple operations, one is arithmetic operations. So let's say f of x plus 1 upon f of x, add it and it's inverse multiply it. Then you get it band pass, band stop. So there means you can have a band of your interest and you can reject that band of your interest totally. I want, let's say somebody, I do not want that somebody. That means I should have a function and I should have the inverse of that function and I will do 2 operations. One is adding and another is multiplying.
This is a convolution.
So no, it's not a convolution. Convolution is not that. Convolution is actually something is there and you gradually pass it on plastic or that amount of common area which is actually giving, so that is actually telling about that total energy or total this spectral density. Anyway, so this is actually published in Wall Street Journal. The business. So this is Wall Street Journal. This is Prof filter quickly. So this is actually they were asking L band 430 mega, 25 mega bandwidth. So I made band pass filter now 100 times better. Two order. So you can observe it this one. And here I played with various sorts of coupling, electric coupling, magnetic coupling, mixed coupling, both electric magnetic. So by relating actually different way and different. So this is my actually simulated filter, which was meeting the specs, and you can identify all the 10 poles. 10 poles would have in the return loss 10 such not yet. Normally people cannot actually have. They will have 3, 4, 5 will be happy. So I wanted to have all 10. So I kept on doing. So this is actually the figure. This is and I also started generating. See, that is what it is. So much curious about mathematics. So I wanted to do this coupling matrix. This is called coupling matrix. To develop and make a filter. A filter synthesis software. It was there since 2000. My every work took 10, 20 years like that. Still I am working on that. I don't do this work, publish 10 papers, then another work, all fundamental work. None of the work is not perfectly. So this work is again, research scientist asked me, I said I am a doctor from Oxford. I told them specifically. So this is actually this coupling matrix, that result. So coupling matrix is standard. You are seeing this knot is coming 60 degrees. So that is elongated person. So now actually this is the measured result. This is the fabricated. Because it is black, so you cannot see this fabricated. This is the measured result. Both wide band channel 2 and narrow spectrum channel 1. So this is the measured result from this one. So on getting this result, I called Professor, my supervisor. That was the first time he came to me. Then he patted on my back. That's the only time I entered. So this is again a software I developed. So because the aim was, the journey was still then, because I thought, see, anything for any subject, actually there are two halves. One is analysis, another is synthesis. If you really want to be called as a master, so one should know both the analysis part and the synthesis part. So analysis in our world, for our world, the engineering world, so when the blocks or the systems are given, you predict the response. That is analysis. Okay? And synthesis is actually the response which is asked, you are building the blocks. So that is what the synthesis is. So that is actually, then I thought I should be master of both. And normally I find somebody is a master in one field. I can analysis or synthesis. So those things are over. So I wanted to go into the software part, and which I started since 2000 only. But I was not able to do much because I was involved so much into the background. So this is the software, this is the GUI made, and I can congratulate or mention actually some interns from Calcutta University actually helped me. And of course my own son was also have done BTech from here, radio physics and electronics. So initially some 12 people joined, and later on due to the COVID time, then he was asking me, I wanted to do some work like you. I told you are too young, my work is doctoral, postdoctoral level, so I do not want to get disappointed too much. Then I said I can work with you if you can manage some more students. So I will divide and among them we discuss, and every weekend we will be having a meeting. So since 2000 and after 2 years, almost 1.5 years, they went on doing something. But anyway, what I actually taken up initially, still going on, it's not final yet because I do not have any students. So developed a PIT, like two LD students of PIT, Vishan Mishra, genetic algorithm, and Muhammad Imran, general synthesis, and 3 UG groups of PIT Mesa. Finally, a group of 9 students from IRP. So this is your part. So, so that way also I feel actually glad. Calcutta University, led by Argalit Pal and close Purnamka. They are the key contributors. So this is actually this one. Now quickly. So this is actually the analysis which I do not value for anything. Why I do this? So I must have a something. So I am finding here. The butterwork unit is here and it is actually gradual. JV said that because the experiment is very simple thing. One can feel it also. If you have length straight, then if you just group it down, then obviously this grouping is actually gradual. Now if you this part, if you make a loop, then what will happen to that? That will come closer. That's semi-shape. Then if you make in this line, that is the loop kind of thing, then it will not further. So it is actually just for actually I. Quite simple. So here the Jefferson who is ultra. Matlab you have little in stop pad, you do not have little in pass. And in elliptical you have both. And it's very difficult to design in elliptical. So what we normally do, Jefferson is very good one. We will put some transmission zeros, which you can do it. So transmission zero realization is a very important thing in realizing filter. Normally people do not understand transmission zero how to practically get it done. So you have to, between the two resonators, actually there is a direct coupling. Or between that two resonators, if you give an indirect path that will give opposite phase, then they will cancel it out. Then you will put a transmission zero. So this is general coupling matrix. Then the mathematics actually synthesis which they have done and other people have also done. So it will be very boring for you. So ultimately there are lots of mathematics involved. You have to do it. Polynomial synthesis, then denormalization, then coupling matrix generation, then coupling matrix denormalization, then ultimately you will get it. Then I have applied because it should be a robust one, just not some single band. So I wanted to do it from single band to multiple band pass and asymmetric symmetry. Both band pass, band stop. Band stop is not there in the market yet, but I have done it little bit, but I wanted to do it further modifications. Once I complete it, then I will market it later on, after guitar. And I still know actually it will not be done. So this is actually a band pass. I have put a transmission zero there, equal band. Asymmetrical, so the formula is given, because you know here, this is very interesting, you can feel it. So this is actually what is the value, it is actually plus minus j b by a. So you get it. Anyway, just quickly finish. So these are all examples they have done, multiple band pass and stop. They have done. The complementary generation, and this is genetic algorithm. Finally, these few codes I want to do here because learning is just like that. Don't know. Just don't know. Education purpose is to replace an empty mind with an open. That is should be the whole part. The highest education that the highest education is that which does not merely gives us information, but makes our life in harmony with all things. Otherwise, education. Educating without educating heart is good. Then preparation of mind. One should not do anything on this heart without courage. Then no challenge lena jorura hi nahi. You see that? That is better. You will not make mistakes. You will never do anything in this world without courage. It's the greatest quality of the mind next to you. Then in solitude, a contemplation is there. In solitude, you find clarity. In independence, you find strength. I want to remain. Then self-satisfaction and fulfillment. There are 2 more slides. Be a free thinker. जो हम लोग का प्रॉब्लम है देश में, दुनिया में, ये प्रॉब्लम है. Be a free thinker. Don't accept everything you hear as truth. Be critical and evaluate what you believe in. Evaluate for. Maybe you are wrong, but dynamism rakho, adaptism rakho. The quality of your word reflects the quality of your character. किस क्वालिटी का काम आप कर रहे हैं? कौन क्वालिटी का आदमी कुछ? The quality of your word reflects the quality of your character. Focus on excellence in all you do, success will come. This is my well-taken wisdom. Thank you.
Thank you, sir, for sharing many with us.
Finally, one thing, curiosity is the one thing invisible in nature. So keep having curiosity. The first love is only a little space, a lot of things. And last my quote, which is copyright. This is my life realization. And which is actually a purpose of this.
And any questions from the audience?
Any question, anybody, any question. I am very